Okay, section 8.2. We hit on this before we left, and some of you were probably like, "Yeah, I got this," and some of you are like, 8.2. I don't remember that at all. So let's kind of start from the beginning here, and we'll set it up around this problem here. Okay, based on a study conducted by the Gallup organization, 76% of Americans believe that the state of moral values in the United States is getting worse. I think we actually did this problem in class. Now that I look at it. Suppose we obtain a random sample of 60 Americans and determine which believe that the state of moral values is getting worse. Describe the sampling distribution of the sample proportion of Americans with this belief. Okay, so we're going to start by saying this. P is the proportion of all Americans who believe moral values are getting worse. And for this problem, P is equal to 0.76. Okay, so we're assuming that 76% of all Americans think that. Okay, now suppose I take a sample. Take a sample of size n equals 60. Can I calculate a percent of those that think that the moral values are getting worse? Yeah, let's look at the first. Let's say the first sample. Okay, so the first sample. Is it possible that I could get a sample that where 78% say that they believe moral values are getting worse? Yeah, the population average is 76. So if I get a sample, I could get 78. Suppose I take a second sample. Would it be okay if I got a 75%? Sure, third. 76.2%. All right, fourth. I might get a 73%. Fifth, I might get a 78% again. Sixth, 87%. Is it possible that I could get an 87%? If the population average is 76%, is it possible they pick a random sample, okay, random, of 60 people and got 87%? Sure, it could happen. Is it likely? Not likely, right? Okay, so let's take a look at, let's draw a sketch. Let's do the sample distribution for all samples where n is 60. Okay, so I'm going to put 76 on here. So I might get a 78, a 75, a 76.2, a 73, maybe an 87 or something, maybe. But would you agree that they're going to mostly bounce around 76? Since that's my population percent, I'd be surprised if I got a sample of 60 and got 50%. Okay. This right here ends up being approximately normal. Okay. So this is a sample distribution. It's approximately normal. Under certain conditions. Okay, I need to define something first here though. These sample percents, we call this p hat, are my samples. So p is the population, p hat's a sample. So this is a sample distribution of p hat. Okay, and we're going to say the average mu sub p hat is 76. Okay, and this is normal if n times p is bigger than 10 and n times q is bigger than 10. That means 60 times 0.76 is certainly over 10. And 60 times 0.24 is greater than 10. Okay, so we're just checking those. If those conditions are true, this is normal. Okay, when we talked about means or averages, n had to be bigger than 30. So that's different. Means n is bigger than 30. Proportions, we've got this condition right here. Okay. All right, and we also have another great result. And we have the standard deviation. Hopefully this is ringing a bell from class. Is PQ over N. It's this nice formula. So let me go ahead and write this. So the sample distribution for X bar, P hat is normal if NP is bigger than 10 and NQ is bigger than 10, and the mean is whatever the original population was, and the standard deviation is the square root of PQ over N. Okay, so let's look at an example here. Okay, let's look at this guy. Okay, according to the National Center for Health Statistics, 15% of all Americans have hearing trouble. Did you hear that? I know, it's old. I'd hate to work in a hearing testing office. Probably get tired of jokes like that. In a random sample of 120 Americans, what's the probability that at most 12% have hearing trouble? And then we'll look at B in a second. So we've got P is the percent of all Americans with hearing trouble. I think I have selective hearing, right? So I get to choose what I want to listen to. I think we all do. So that's 15%. So A says this. In a random sample of 120, what's the probability that at most have 12% hearing trouble? So this is, I've got lots of P's here. This is a capital P for probability that my sample is at most 12%. Okay. What's in a random sample, what's the probability that at most 12%? So that P hat is less than 12%. Well, let's look at this. Let's look at the sample. Actually, I'm right over here. Let's look at the sample distribution of P hat. It's going to be normal if NP, 120 times 15, is over 10, which that is 15% of 120 is certainly over 10. And 120 times Q, which is the complement. Okay, so these are my two conditions that have to happen. So it's normal. And the mean is 15%. It's what P is over here. And the standard deviation is the square root of PQ, 15 times 0.85 over 120. Let's go ahead and calculate that. So it's going to be the square root of 0.15 times 0.85 divided by 120. And that's going to be 0.033. Okay. And so the question is, remember, these are all samples. Okay, that's the main thing to catch. These are samples, percents. Okay, so what's a sample that I get 12%? Right, at most 12%. So 12% or fewer. Okay, likely or not. So the percent that I'm at, the probability that my sample is less than 12%. Well, this is a normal curve. So I could find the z-score, I could look it up on the table, or I could just use my normal CDF, and I'm going to put in negative, just a really small number. Okay, because this curve mathematically goes on forever. 0.12, here, let me write this so it doesn't get in the way. So normal CDF, negative, really small number, 0.12, 0.15, 0.033, right? This is the min, or the lower bound, the max of my shaded area. This is the mean, and this is the standard deviation. And if I do that, we'll go second vars, normal CDF, negative 9999, comma, 0.12, 0.15, 0.033, and you get 0.182 or 18.2%. So question answer A then says, hey, what's the chance if 15% of the population has hearing trouble, what's the chance that I pick a sample of 120 and 12 or less percent have hearing problems? And the chance of that happening is 18.2%. There's a lot of percents in here. So the chance of me getting a sample with 12% or fewer having hearing problems is 18.2%. Okay, let's get B on here. Suppose a random sample of 120 who regularly listen to music during headphones results in 26 having hearing trouble. What might you conclude? Okay, so B, I've got 26 out of 120 have hearing trouble, which is 26 divided by 120. That'd be 21.7%. Okay, so what can I conclude there? Well, can I just say, well, that just happened? Well, let's look at this. Actually, I'm just going to use the same picture and I'll just change it to orange. So now we're up here at 21.217. So what's the chance that I get a sample of 21.7% or more that have hearing problems? What's the probability that P hat is over 0.217? Okay, more extreme, right? So this right here is more extreme. So I'll do normal, CDF, minimum, or lower bound, upper bound, something really large, the mean, and the standard deviation. And so if I do that, I get 0.217, 9999, 0.15, 0.033, and I get 0.021, which is 2.1%. So I've got 2.1% chance of randomly selecting people and having them have, in that sample, having over 21% that have hearing troubles. Okay. All right. So is that likely to happen by chance? No. It says that listening to music while on headphones probably causes them to have more hearing problems. Okay. So we get to use these numbers to kind of make statements or general statements about what's going on here in life. Okay, so we've got a couple of topics for you. You've got 8.1, which is about means. are averages, right? X bar is a sample, U is the population, and then 8.2 is about proportions, and P hat is my sample percent, and P is the population. Okay. All right, so give those two a shot. We will talk on Thursday. If you start working on this and you get to some problems where you're like, what? I don't get this, then just stop. Okay, and ask me some questions and I'll clarify it and we'll do some more examples or whatever you need. And then we'll move on from there next week. But we'll keep on this all week long, whatever we need to do to get you dialed in. All righty, we will talk to you soon.